Expand x to the negative 2y times y to the fourth over x squared minus x to the fourth over y squared. This is the only problem with the whole issue, right? With the whole thing. This is fine, right? So if I fix that, and this might be something as I copy it out of my book, I might put it on my paper this way. All right, so x to the negative second y actually means y over x squared. Again, it's written as a whole number structure, there's no fraction in it, which means that everything there is a top object. A negative power on top belongs on the bottom, so you fix that. Everything else about this problem is perfectly fine. Y to the fourth over x squared, nothing wrong with that. There's one y, there's one x, the powers are positive. Minus x to the fourth over y squared, there's one x, there's one y, powers are positive. So job number one's been taken care of. We fixed the problem so that everything's positive powered. There's one of each letter within each term. Now we're ready to distribute. Y over x squared times the first thing, y over x squared times the second thing. So if I do the multiplication, the red one first, y times y to the fourth, this is y to the first, right?
Yes.
Right. Y times y to the fourth makes y to the fifth on top. X squared times x squared makes x to the fourth on the bottom. The rule says if you're multiplying a letter by itself, you're going to add the powers together. I do the green multiplication. Positive times negative makes a negative. On top, y times x to the fourth makes x to the fourth y. X squared times y squared makes x squared y squared. Okay. And again, I can see there's two x's and two y's. I don't care. Until I've multiplied it out to get this top and bottom as simple as possible, I don't care about things the same on top and bottom. Looking at each term individually, what's wrong with the red one?
Nothing.
Absolutely nothing. There's one x, there's one y, the powers are positive, it's ready to go. The second term, there's too many x's, there's too many y's. So Liz, what would the second term become?
X squared on top and 1 to the first on the bottom.
Perfect. X squared on top, 4 is bigger than 2, so that's where x belongs. 4 minus 2 is 2. 2 is bigger than 1, so that's where y belongs. 2 minus 1 is 1. Notice I just put y instead of y to the first. If you put y to the first, it's not wrong. The first term, y to the fifth over x to the fourth, is still part of the final answer. Make sure you do give me both pieces of that final answer when you do this. All right? But that's where you go with that. And again, you're done when each term looks like these terms. There's one y, there's one x, the powers are positive. That term's perfect. There's one x, there's one y, powers are positive. That term's perfect. Okay? Once you get one of each letter, you're done. And the powers are positive, of course.
What about